Hello everybody, welcome to Highway Geometric Design, which is a part of your subject CE532. So I am Jeevanami Gage. I am a design engineer working in Road Development Authority. So from here onwards, we will be looking at how to do highway geometric design or how to design highways with theories and with practicals using the software called Civil 3D. So in my first part of the lectures, I will describe you how to do geometric design using highway engineering theories. So this is our outline. So I will give you a basic introduction. Then I will give you the basic design criteria, how to design a road, what are the things we need to consider when designing roads, that is basic design criteria. Then we will be looking at the cross-section of a road. So before designing or before doing anything related to highway, we need to know what are the things we have in a road. So under the cross-section of a road, we will learn in that. Today we will learn these things. Within this lecture we will learn these three parts: introduction, basic design criteria and cross-section of road. But under this course we will be looking further into side distance of roads, horizontal alignment, super elevation, vertical alignment, and finally horizontal and vertical coordination. So these will be taught to you as a part of theories. After that, I will be doing these things in a software called Civil 3D, how to design roads using that Civil 3D software. So then I will move on to the introduction of my course. So geometric design is an integral part of highway engineering. So if you are doing highway engineering, geometric design is very important. You need to know how to do geometric design, or otherwise how to design roads. So it is concerned with the positioning of physical elements according to standards and constraints. So I will describe it more in the next slide, but before that, the basic objective of geometric design is to optimize efficiency and safety while minimizing the cost and environmental damage. Basically, when doing geometric designs, you have to have a optimized design so that it will give you efficient road, or otherwise a good user-friendly or driver-friendly road while maintaining safety aspects as well as minimized cost and minimum damage to the environment. So what are the elements we talked in the previous slide? I told you we are concerned with positioning physical elements. So what are these physical elements? There are three physical elements, that is horizontal alignment, vertical alignment and cross-section. Horizontal alignment is the one we see from a plan view. That means if you see a road on a plan view, so if you think of a way you see a road on a Google map or Google Earth, you will see the road something like this. So you can't see any elevations here, just a plan. You can see the straight portion, then you can see the curved portion. So you only see the plan view of the road, no elevations. That is called the horizontal alignment. Then vertical alignment means the elevation view of a road. So if you consider this road, you can see this is coming to a top elevation from the bottom elevation. So we call it vertical alignment. Then you have the cross-section. Cross-section, as you know, is the width component of the road. Here, if you consider, you have the travel lane where your vehicles are expected to travel, and there are some other notations which I will be teaching you in later slides. So the combination of three will give you a nice looking road to you. So you have to arrange these physical elements in such a way that we get a good efficient road, but we have to ensure that your construction cost of that road is minimum. Minimum is, when I am saying minimum, you have to ensure that the quality is there. You can have a road with minimum cost, but the quality may not be there. So when I say minimum cost, you have to ensure that it is a good quality road, and you have to minimize the environmental impacts too, because if you have so many environmental impacts, even though you create or you construct a good road, there will be some adverse effect to the environment due to your road. So if you are a good designer, if you are a good design engineer, if you are constructing a road in a proper manner, you will be minimizing the damages to the road, minimizing damages to the environment. That is the best way to do good designs. Then, to do a good design, you have to have design standards, because when I say horizontal alignment in the previous slide, when I say horizontal alignment, you need to know what are the curve radius you have to select for the curve, what kind of straight lengths you can adopt, how much of length you have to select to design the road. Then you have the vertical alignment constraint. That means what kind of gradient or what kind of slope you have to use for your road. So you have, if you see here, you have a slope here on the road. So what are the maximum slopes? What are the minimum slopes? What kind of slopes you have to ignore? What kind of slope you have to select? So they have to be decided by someone, otherwise you cannot design a road as you think. There are standards for that. So when you come to the cross section, what are the lane widths? What is this? We are calling this shoulder. We have a drain scheme. So what are the type of drains we have to use? What are the lane widths? What is the curve radius? All those things has to be known by someone to design a road. So to get a good or the best practice or best design roads, there are several guidelines in the world designed to create or design roads. So we call them design standards. If you do structural design or concrete design, you have BS standards, American standards. Likewise, for road design, you have separate design standards. It will tell you what kind of road you have to design, what are the road widths, what are the curve radiuses. Then the most important thing, when you are designing a road, you have to ensure, you have to think of what is the speed of the road, what is the maximum speed of the road. So when you are using that maximum speed, what is the minimum radius you have to adopt for curves, those things are illustrated in design standards. So they are developed by engineering professionals. So it will, they are designed considering the requirement of road users as well as other stakeholders. So adopting these standards, people can, or the design engineers can design roads in proper manner. So these standards will be changed or will be used in several ways. That means in one country they use one standard, in another country it will use another standard. So for example, in Sri Lanka what we are using is RDA road design guideline. If you go to USA or United States of America, they have ASTO design guidelines. But inside America, there are several states, New York, Washington, likewise. So those states have several guidelines for road design. So according to the situation, they have to use various guidelines. But all these guidelines they ensure you have an efficient road while minimizing the cost as well as the other adverse effect to the environment or other road users or the other public spaces or the people. Then you have some examples, design standards. So in Sri Lanka we have geometric design standards of roads. It is published in 1998 by Road Development Authority. Then you have geometric design standards of expressways published in 2017 by Road Development Authority. Then you have Guide to Road Design Part 3 for geometric design published in 2015. We call it as Offshores 2015. So it is published by Australia. So in USA they have Geometric Design of Highways and Street 2018. That is the latest publication. So it is also known as AKA means also known as ASHTO 2018. So that is published in USA. So these guidelines are periodically updated to provide more satisfactory design, because the world is changing every day, so we have to create more sustainable or more suitable design standard to the modern world. So these standards are changed periodically or modified periodically to get satisfactory design for roads. Then we will be looking at the road functional classification. So before designing roads, we have to know what are the functions of a road. We have two basic functions of roads. That is, provide mobility between centers and provide access to land and other properties. So provide mobility between center means it is giving a way to travel between two locations. So if you consider you are traveling from Colombo to Kandy, there are several roads. So we call it, we have a mobility. We get the mobility from, let us say, Kandy Colombo Road. So you are getting the mobility from Kandy Colombo Road to travel from Colombo to Kandy. So then after that there are some other roads. That means if you want to go to some other minor location, or if you want to go to your home in Kandy, you have to use another small road, A1 road, or the Colombo Kandy road is a main road. Then you have to use some other small road to go to your property or your house. So that means you are going to access your property, you access your land through some other roads. So that Colombo Kandy road provide more mobility, but the small road to your house provide more accessibility. It helps to access you, but the main road provides more chance to mobilize. That means it has more speed. So if you consider this chart, you can see expressways have more mobility but less accessibility. That means you can't stop everywhere at the expressway. You can't stop only after going from an interchange. So you have less access but more mobility. But when you come to AB class roads, that means I will tell you what are the AB class roads later next slide. But when the accessibility is coming high, your mobility will be getting lower. When there is more mobility, you have high speed. When there is low mobility, you have high access. So the CDE class roads, or in other words, the roads we are using to access our houses have more access, but low mobility, we have less speed. So these are the road system in Sri Lanka, which I talked earlier in the slide. So Class E roads means the expressways. You know, if you go to Google Map, you will see E1, E2, E3 likewise for expressways. So E-class road means expressways which we have high mobility and fully access controlled roads. So you cannot access the expressway from everywhere. You can access the expressway from a particular location called interchange. So we call it fully access control. When you go to A-class roads, still there is high mobility most of the time, but there are it is less compared to expressways. Mobility is less compared to expressways, but accessibility is high. So going down, you will see the mobility decreases, but the accessibility increases. So A-class road, they are mainly the roads within two provinces. A-class roads are the roads within two provinces. Then B-class roads are the roads within a province, major roads within a province. And AB and AC class roads are major roads but in shorter lengths. So they are within a province but they have high importance. So that is why I call them AB or AC. So B class roads, they are within a province. Especially this E, A, AB, AC and B class roads are governed or maintained by the Road Development Authority, and then the C-class roads are maintained by the Provincial Road Development Authority, or we call them PRDA. Then B and E-class roads are the small roads where we use to access our homes or villages. So the accessibility will be increasing downwards, but mobility will also decrease downwards. So going upwards, you will see mobility increases and the accessibility decreases. Then we will look at the basic design criteria. What is the design criteria we have to adopt when we are designing a road? So there are several criteria we have to adopt. So I have listed out some of these. I will explain this one by one in here. So functional classification, I told you what type of road we are designing, what is the mobility, what is the accessibility, whether we are giving more mobility or more accessibility. That is called the functional classification. And the level of access control, how much you are allowing to access that road, how much you are allowing to how much you will limit. So if you consider an expressway, we are not allowing the bicycles or three-wheelers to access that road. So we are keeping some kind of access control for smaller vehicles in an expressway. So that is what you mean by functional classification and level of access control. Then you have the topography, land use and physical features. So these criteria also should be considered when designing roads. So topography means what kind of land, what kind of area you have. I will be discussing in detail in a later slide under vertical alignment, but in general I can tell you topography means whether you have a flat land or a mountainous land, or kind of mountainous and flat combination land in that area where you design the road. That is meant by the topography. Then land use means what kind of use in the land in that area. So if it is an urban area, you have high land use, you have buildings, schools, offices, industrial zones. Likewise, you have high land use. If it is a rural area, the land use is very low. You have small houses here and there. The congestion is very small, so the land use means whether it is urban area or a rural area or suburban area. Likewise, on the other hand, the physical features are there may be rivers, historical locations, buildings, trees. So they will affect the design of your road. So also we call them constraints which will affect your design. If there is if you assume that you are constructing, so you are designing a road in a new area. If you are supposed to design a road in a new area, if there is a temple in that road trace, when you are designing, if you have a temple in that road trace, you cannot demolish the temple. You have to redesign the road so that the temple is not affected. So we call them constraints when you are designing. So you have to address those constraints while you are designing. So those are the topography, land use and physical features we encounter in road design. Then you have traffic volume, capacity and composition. So traffic volume means how much of traffic you have. That may be traffic volume per hour, or traffic volume per day, traffic volume per some period of time. So you can measure how much of traffic in that road. When you are designing the road, you have to measure that volume and then you have to forecast the traffic for a future period. That means from the date from today to 20 years ahead or 15 years ahead, what kind of traffic might be there. Likewise, you have to design the traffic volume when you are designing the road. So then what is the capacity of that road? So how much vehicles that can be accommodated in that road section. So if it is a smaller road, if there are so many vehicles coming, the capacity of the road is small, so your road will be getting congested. So likewise, you have to think of the capacity of your road. So depending on the capacity of your road, you have to accommodate 1 lane, 2 lane, 3 lane, 4 lane. Likewise, how many lanes you have to use. Then the composition of your traffic. Composition means what kind of vehicles you have in your road. If you have so many cars, or if you have so many lorries, or you have so many trucks, if you have so many three-wheelers or bicycles, you have to design, or you have to consider that fact in the design. So what kind of vehicles, what is the composition of the vehicle, how many percentage of trucks, how many percentage of cars will be going in this road. Depending on that, your road cross section may be varied, your design speed of the road may be varied. So these things you have to consider. Then more importantly, the safety considerations. So it is an integral or essential part of road design. You have to ensure that you provide enough safety consideration while designing the road. So when you are designing a road, you have to use proper radius for curves. It depends on the design speed of the road. So we will be discussing them. Then you have to provide guardrails if you have sharp curves and steep slopes. So you have to provide guardrails which will prevent the vehicles from falling down to the steep slopes. Then you have to use proper signboards on roads. You have to use proper lane marking, and if there are so many bicycles going on that road, you can have a separate bicycle lane. So the bicycle users are getting more safe driving. Then the geological, climatic and drainage consideration. So in that area of you where you design the road, there may be landslides, or there may be slope stability issues, or there may be flooding, there may be marshy lands, or there may be settlements on the ground. So we have to consider these things when we are designing the road, and we have to address those issues or address those constraints before it will be a more hazardous problem to your road. So we have to consider those things also when designing the roads. And the other one, environmental consideration. So we have to minimize the damage to the environment when we are designing a road. So let's, for example, to design or to construct a road, once you design the road, when you are constructing it, after designing, when you are constructing it, if you are cutting a mountain, it will be a huge environmental impact. Cutting mountains means it will affect the trees or the fauna, flora, the animals or natural habitats in that area. It will affect. Then it will affect the groundwater table. If you can remember this, there was a certain issue on the Uber province regarding a tunnel. So there was water issues for the people. So you have to consider these things. So if you have so many mountains and you have so many rock cuttings, so many cut sections in the mountains, sometimes you can accommodate tunnels in that area to minimize the cuttings of the mountains. But in the meantime, you have to ensure that the people will be less affected by the tunnels. And also you have to consider about the wildlife or the animals or the species in that area. So we have to minimize the damages for them also. Then one of the most important things, economy and financial considerations. So whatever you do, you have to do it economically, and you have to do it within a minimum cost, as well as within the best standards. So you can design a road with best standards, the best possible way, but if it is taking so much of money, that is not a good design. You can design a road with minimum cost, you can construct the road with minimum cost, but the quality is not there, so that is not a good design. So you have to balance the economy and the safety and the comfort of the road within economy and financial consideration. Finally, but even though it is final, that is one of the most important things: design speed, design life, and design vehicle. So design speed is what is the speed we are allowing in that road. Actually, there are two things we have to consider. Sometimes we are allowing the road users to use the design speed, or we are not allowing the road users to use the design speed. That is something like this. Let us say we are designing a road with a speed of 80 kilometers per hour. That means in that road the drivers can go at 80 kilometers per hour without any problem. But when you are doing the signboards, or by government regulations, we will tell you can't go beyond 70 kilometers per hour. That is for the safety, that we are designing the road for 80 kilometers per hour, but we are allowing only 70 kilometers per hour. The additional 10 kilometers per hour is for safety. So that is called the design speed of the road. What is the speed? What is the maximum speed you are designing the road? So this design speed affects the radius of the road. Horizontal, we call it horizontal alignment, which we will be learning later. So it affects the horizontal alignment as well as the vertical alignment. So design speed is what is the maximum speed you are allowing in that road. Design life, that means how much of the road, how much is the life of the road before doing any rehabilitation or before doing a modification to the road. What is the design life? That means after the design life you have to re-modify your road. That means you may have to increase the road width, you may have to do a new layer on the road, or we call it overlay. That kind of things may be there, but within the design life, your road should be the road should provide its safety and comfort driving to the road users within that time period. Then one of the most important thing, design vehicle. Design vehicle is the vehicle that is supposed to that the design vehicle is the largest vehicle that is frequently running on that road. So this design vehicle affects the curve radius of the road. So if you have a very large vehicle, you should have larger curves, otherwise these vehicles cannot be turned in that road. So, but when you are selecting the design vehicle, you have to select a vehicle that is frequently running on that road. Let us say you have I will move on to the next slide to show you the design vehicles. These are the design vehicles that we use for RDA. So you have this single unit truck. You have the dimensions here. Single unit truck, you call it SU. So its overall width is 2.6 meters and it has a turning radius of 12.8 meters. So if this truck is very oftenly running on a road, so you have to that if this truck is the maximum length vehicle in that road, you have to design the road using to cater single unit truck, or you have to assume that this truck is frequently going on that road. But if you are going to design the same road for this combo truck, which is rarely going in that road, let us say only once a year this truck is going on that road, so you don't have to design a road for a combo truck which rarely runs on that road. You have to design the road for a design vehicle that is frequently running on that road, but that frequently running vehicle should be a larger vehicle. Otherwise, there is no point. So if you say if there are so many cars in that road, you cannot design for cars, but you need to design a larger vehicle such as single unit truck, SU truck, or combo truck, intermediate semi-trailer, WB12 likewise. So these are the dimensions of design vehicles. So the design speed, design life, and design vehicle are very important part in basic design criteria. So these are the main things we have to consider when you doing geometric design. Then I will move on to the cross section of the road. That is the last part we are discussing in this session. So what is the cross section of the road? These main elements of cross section of the road is extracted from the RDA design guidelines. Since we are living in Sri Lanka, we are we have to consider about the local roads. So these definitions are extracted from the RDE design guidelines, which I told you earlier, the guideline we used for local road design. So these definitions are taken from this. So the values given in these topics in the later slides are extracted from RDA design guidelines. First, the term carriageway. It is the area where vehicles are expected to run. So if you see this image, you have two yellow marks. So the width between these two yellow marks or the lane edges are called the carriageway. So this is where your vehicles are expected to run. So in Sri Lanka, we are calling the desirable lane width is 3.7 meters. But it's kind of a larger value. Normally we are using less than that, maybe 3.5, 3.6 likewise. And if you are using a minimum value for the road width, the absolute minimum should be 3.1 meter. To use lane marking, at least your road should have a width of 3.1 meter. So your design vehicle width would be 2.1 to 2.6 meter. So that means if you have 3.1 meter width of the road, your design vehicle may be enough to travel in that road. You can see here you have the overall width of the vehicle 2.1 to 2.6. Then we will move on to shoulder. Shoulder is the paved area. Paved means you have asphalt here, this black color material, we call it asphalt. So after the lane you have some extra width asphalt here, we call it shoulder. It will be used as to give a lateral support to the pavement. This part will give you a lateral support without going out. So one function is to give lateral support, the other function is to use as an emergency maneuvering or parking. If a vehicle is break down in this area, the vehicle can be parked in this area. So that is why we are using a shoulder. So the desirable shoulder width is 3 meter and minimum shoulder width is 2.4 and the absolute minimum shoulder width is 1.8. But locally we are not practicing these values since these are too high values. So if you adopt these values, your road width will be very high. So the adjacent land have to be acquired to construct that kind of road. Usually, if there are not expressways, we are not using these kind of values. Usually, we are using 1.5 or 1 meter, 0.5, likewise for shoulder width. You can see there another soil area or a gravel area after the paved shoulder. This is the paved shoulder. Then after you have some gravel area, that is called the soft shoulder or verge. So this one we usually call paved shoulder, or in Sri Lanka we call it hard shoulder. This gravel part you call it soft shoulder. Then we will be moving on to the drains. So adjacent to the road you have drains to drain off the water collected into the road, or when in a rainy situation you have to use drain to collect the water and drain them away from the road. So you can have earth drains, otherwise you can have concrete drains. There may be this kind of V-shaped drain, or sometimes they may be rectangular drains. So usual drain widths are 0.6 meters, 0.9 meters, 1.2 meters. That means that is for these rectangular drains. So if you have a earth drain, that is, drain is formed using the existing ground, so this slope would be 1 horizontal to 4 vertical, that is the earth drain if you have a earth drain in the road section. Then you have cash drains which are used in high cutting sections. You can, that is the drains which we used in high cut areas. So you can Google this thing or search in internet what are called catch drains. You will see what are catch drains. Then you have the center medians. When you have more than 2 lane road likewise, such as 4 lane roads or 6 lane, like multi-lane roads. So the road is divided into 2 parts by having a center median. So it will avoid hazardous conditions from the opposing traffic. So if you are adopting this kind of center median, usually minimum width would be 1.2 meter. That means this total center median width would be 1.2 meters. That means 0.6 meters to one side and 0.6 meters to the other side. Then you have reservation for services in your road, because in the road you have, after the road you have water board lines, electricity lines. Sometimes nowadays you have telephone lines, fiber optical cables. So you have to have some free space just away from the road for these services. So we have to have reservation area for services. So we call it reservation for services. So if you are providing that kind of service area, the minimum width should be 0.6 meters. Then you have something called right of way. That is the area which belongs to the road, not the road edge, but some area away from the road. We call them the right of way. So in roads you might see this kind of boundary in the after some distance from the edge of the road. That is, these are called RDA boundaries. In this image you can see here, these RDA boundaries. That means up to this point, from the center line of the road up to this point, the area is owned by the Road Development Authority. So the people can't do any construction, or people can't do anything. The people can't build any permanent structure beyond towards the roadside of the RDA boundary. If you see this building, this is inside the RDA boundary. So someday this person have to demolish this area so that it will be acquired by the Road Development Authority. So this boundary will be marked on the road just some distance from the road. So it will ensure that if there is a future widening of the road, it can be done without problems to the neighboring houses or industrial people or business community, anything. They will not be affected if you are constructing their houses or business or commercial buildings away from this RDA boundary. We call it the right of way. So that is about the cross section of the road. So in this series we have learned what is highway geometric design and introduction about that. Then we learned about the function of the road. Then we learned about the basic design criteria, what are the factors affecting, or what are the considerations for geometric design of roads. And finally we talked about the cross section of the road. So then under the cross section of the road we learned what are the components of a road. So what are the minimum values and what are the governing values. Those things we learn as under the cross section of the road. So In this lecture, what we have covered is those three parts. So in the next lecture, we will be looking at the sight distance, another important factor in designing roads.